For example 5, we see that our A value is 4 and our C value is -9. So they are not the same, so it's not a circle. We have both of them, the square terms staying in, so it's not parabola, so it's either got to be an ellipse or a hyperbola, and hopefully you recognize that positive times negative makes it negative, so this one is a hyperbola. So in this case, we are going to have to complete the square twice. So we are going to take the 4 out front on the y, and we have y minus 4 for 4y plus 4 cut in half is 2, square it is 4, and then we say minus the 9, and we still have x squared on the inside, and a minus 2x because we took a minus 9 out. -2 cut in half is 1, square it, and we get +1. And we have -43. Again, I'm going to move this to the outside. And we multiplied, or we added 4 here, but we have to multiply it by 4. So we added 16 from the first term, and -9 plus or times 1 means we subtracted 9. So that's going to be -9 plus the 16 minus 43. When we add those together, we get -36 equals 4 times y minus 2 quantity squared minus 9 times x minus 1 quantity squared. Again, we can divide by -36 so that we end up with 1, and that leaves me with I'm going to swap these since the negative's going to switch. So we're going to put the x squared first. So it's going to be x minus 1 quantity squared. And we end up with 4 on the bottom. And the y becomes negative. So it's going to be y minus 2 quantity squared divided by 9, which means that we have a center. Well, before we get to the center is going to be 1, 2. So it's going to be over 1 and up 2. And then we know that this particular hyperbola is going to open left and right. And we're going to have, in the x direction, it's going to be 2. So we go forward 2 and back 2. I think that was 2. Yes, there we go. And in the y direction, it's 3. So we go up 3. Whoops. Where are my vertices? I got lost here. Oh, no, those are my vertices over here. Sorry. Okay, those are my vertices. So now I can go up 3 and down 3 from the vertices. 1, 2, 3. And we can go up 3 and down 3. And create my asymptotic lines. And then we can graph the hyperbola. If we wanted to get particular about it, we could determine the x-intercepts on this, but I'm not going to take the time to do that one. They come out very random, and you know roughly where it's going to be, so I'm not going to be super picky about that. All right, on this last example, what we need to do is, again, complete the square because we see that we've got A and C being equal. They're both squared terms, so it looks like it could possibly be a circle. So we are going to complete the square, pulling the 6 out front. We have x squared minus 2x. 2 cut in half is 1, square it is +1. And then we have +6 times the y squared. Taking the 6 out, 18 becomes -3. -3 cut in half is 3/2. And we square it, and it becomes 9/4. and that equals a negative 25. We added 6 from the x term because 1 times 6 made it plus 6. From the y term, it's 6 times 9 divided by 4, which would be 27 halves. And if we added 27 halves on one side, we have to add 27 halves on the other side. When we add these terms together, we end up with a negative 11 over 2. And because these are both positive, 6 times x minus 1 squared plus 6 times y minus 3 halves squared. In order to make this 1, we've got to divide by a negative, which is going to make both of these numbers negative, which is none of our conic sections, and this happens to be a no solution for this particular circle. Okay, because as we should recognize, we can't have a negative radius, so the answer is no solution. Kind of gave it away by not putting a graph there. All right, hopefully this all helps and you understand conics better, and I will see you all on Monday.